Hi, I'm Steve Shoyer. For my project, I built a ski mountain routing system. The goals of the project were to determine a route for a skier to follow from one point to another on a ski mountain. It uses information about the mountain layout, the ability of the skier, and which trails and lifts are open or closed. It finds the shortest path using distance, using two AI techniques, heuristics and agents. Here's a map of the Sunday River Ski Resort. It's big. There are 140 some trails, 8 mountains, 18 lifts, so it is sometimes hard to navigate. The definite requirements for the project were some representation of the ski mountain in the computer system, a user interface to be able to describe where you were, where you wanted to go, and a way to determine a route using a heuristic that came up with the shortest path. The nice-to-have requirements are some way to verify the route, a way to update the trail status and lift status, and a nice interface using GPS positioning to figure out where you are. As far as what I accomplished, I did meet all the definite requirements. So I have a representation of the mountain in the system, a user interface, and I'm using a heuristic algorithm to find the path. For the nice-to-haves, I did build a verification system using a second algorithm. Real-time trail status update I built but lost the file, and when I recreated it, at that point the mountain had been closed because of coronavirus, so everything was closed. So real-time update didn't help. And the additional interface and GPS I didn't attempt. The system was built using Python with a tkinter interface, uses the A-star pathfinding algorithm, and for the heuristic it uses the straight distance between two nodes. I built a class for and have two agents. One uses A-star and one uses Dijkstra's algorithm as the verification. The mountain representation is a directed graph using the latitude and longitude of different points on the mountain, and has a dictionary that for each node it has the adjacent nodes and the distances to get there. Data sources were the Sunday River Trail Map and Google Earth for actually measuring latitude and longitude of the nodes as well as the lengths of the trails. Here's the system design. Input is the starting and end nodes, as well as a constraint on the maximum difficulty. The mountain representation is this trail data, node data, and closed trail data. That generates a directed multigraph. Then I create the two agents, one using the A-star search, one using Dijkstra's algorithm. They come up with the shortest path and compare the results to verify. And from the shortest path, the shortest route, which is the list of trails to get from one node to the next, is generated. Dijkstra's algorithm basically picks the next path based on which one costs less. And A-star improves upon that by using the same but also adding a heuristic value. So it's not only the shortest path to the next node, but it's the shortest path in the right direction. So it uses the distance to destination also. I'll run a quick demo. Basically going from one side of the mountain to the other, and you can see how the different algorithms compare. Here's my user interface. We'll start at the Whitecap base and go to the Jordan summit on the other side of the mountain for an intermediate skier. It picks a route. A-star visited 75 nodes and took about 1 millisecond. Dijkstra's algorithm came up with the same result, visiting 150 nodes in just about 5 milliseconds. If we go back to the other direction, so we'll start at the Jordan summit and go back to the Whitecap base for an expert skier so they can ski any route. It picks about 21 nodes and 5 trails for its path. It runs about 5 milliseconds, visiting 98 nodes. The non-AI algorithm took about 9 milliseconds and visited 163 nodes. Now, if we further constrained that by removing a couple of trails, the two trails I'm going to remove are Kansas and Roadrunner. We can run it again. It this time took about 8 milliseconds for A-star with 204 nodes, and it took almost 100 milliseconds and 776 nodes for the Dijkstra's algorithm to come up with the same result. So you can see that it's being a lot more efficient using the heuristic. Here's the first path that we took. From this side of the mountain, we went up a lift, skied down, up another lift, skied down, took a lift over and a lift up to get to the top. On the way back, without any closed trails, we just skied straight down from one side to the other. With the constraint that a couple trails were closed, we skied down, took a lift over, took a lift up, skied down, took a lift up, and skied down. Things that didn't work well. Manually measuring the distance with Google Earth, it wasn't as accurate as it should have been. The verification system found that Dijkstra's algorithm was producing better results than A*. That shouldn't have happened. Also, a different cost metric would be better to improve the routes. This system, since it picks distances, sort of leans more toward lifts versus trails because they're shorter. So being able to factor in the time it would take rather than the distance would give you a better skiing experience. Things that did work well, A* worked out very well for pathfinding. It was pretty easy to implement. The verification system worked well because it helped me find errors, and I could make sure that the distance I calculated was no longer than the distance I measured. Otherwise, part of the heuristic requirement is that it doesn't overestimate the cost. Finally, the user interface was pretty easy to use. With tkinter, it was functional and didn't take too long to learn. Thanks.